we finally get sum of the roots, which is u square sine 2 theta by g. Now this is same as the expression for r. So the equation of trajectory, which is a quadratic equation, sum of its roots gives the range of the projectile. Coming on to final property, 2 points at which height of the projectile from ground is same are symmetrically placed from both the ends of the trajectory of projectile on the horizontal plane. So to understand this, let's see this animation. So here let's denote these points. Say suppose this is P, this point is Q, this is R, this is S, this is our origin O, and this is T. So from the figure it's clear that PR is equal to QS. So the height of these 2 points, that is P and Q, are same from the ground. So from the symmetry of the parabola, it's clear that the distance of P from origin O, that is OR, is equal to distance of S from the point T. So if you can take another 2 points at the same height, suppose we have taken another 2 points, this is P1, this is Q1, and drop perpendicular from P1 and Q1 to the ground plane. Say this is R1 and this is S1. So here also we have OR1. This will be equal to S1T. Now let's discuss the path of a projectile when it is projected from a point which is at a height h from the ground. So let's see this animation first. Okay, so here as you can see that the projectile is being projected from a point. Say this point is O, and this point O is at a height h from the ground. The velocity of projection is again u, and the angle of projection is theta. So we'll try to find out the time of flight, that is the time taken by the projectile to travel the distance between point O and point P. The point P is the place where the projectile touches the ground, and also we are interested in finding the range of the projectile, that is, suppose this point is Q, so range is QP. So let's find this one by one. Now we can see here that there are two components of projectile velocity. One is along horizontal direction, which is u cos theta, and another one is along vertical direction, which is u sin theta. So the displacement along y direction, that is along vertical direction, is h. If we take the downward direction positive, then displacement will be plus h, and the initial velocity along y direction is u sin theta, which is vertically upwards, so this velocity would be minus u sin theta, and the acceleration along y direction is g, which is again downward, so we'll take it as positive. So we will use the following formula s is equal to ut plus half at square, where s is the displacement, u is initial velocity, and a is acceleration. The displacement is h. H will be equal to initial velocity is u sin theta, which is in the opposite direction to the displacement, so we are taking it as negative, plus half at square. Again here acceleration is g, so and g is in the downward direction, so we'll take it as positive, half gt square, or half gt square minus ut sin theta minus h is equal to 0. So here we get an equation in quadratic equation in t. So the roots of this equation will give us the time of flight. So here t will be equal to u sin theta plus minus u square sin square theta plus 2gh by g. Now we'll discard the negative part, because in that case the time will come as negative. So finally we'll get time is equal to u sin theta plus root under u square sin square theta plus 2gh by g. So this is the time of flight. So as you can see from here, this is our time of flight. Now to calculate the range, what we'll do is we'll simply multiply the time of flight